Okay, so we're taking a look at our element box practice. You should have your sheet of paper out, and we are going to look at how to fill this out. So please fill this out along with me as we go. So in this case, this 2 right here, that is my atomic. What do you think it is? Atomic mass or atomic number? In this case, it's our atomic number. He is our element symbol for helium. So we fill that in as helium. And last but not least, 4.00, that's the one with the decimal. So that is our atomic mass. Okay? Now, those things tell us a number of things. We talked about this in the video for our notes, and we talked about the fact that atomic number is the number of protons. So if my atomic number is 2, my atomic number tells me there are, in fact, 2 protons. Now, the interesting thing is, if we look at this, if we take our atomic mass, so if we take mass minus our atomic number, that actually equals the number of neutrons. So in this case, 4 minus 2 gives me 2 neutral neutrons. So we have 2 positive protons according to the atomic number. We have 2 neutral neutrons because 4 minus 2 is 2. But now, interestingly enough, we want to have a balanced charge. We actually have to have the same number of protons as electrons because protons are positive, electrons are negative, and they need to balance out to 0 to be neutral. So in this case, if I have 2 positive protons, I also have 2 negative electrons. And that's how we're going to fill out this box. This is our atomic number. That tells me the number of protons, and it also actually happens to tell me, in this case, the number of electrons, because they need to be the same to get to 0. My atomic mass minus my atomic number gives me my number of neutral neutrons. Okay, so if we look down at the bottom part of this page, this is where you need to have your periodic table. I have given you a periodic table, or you can use the one in the book, or you can use the interactive one on your Chromebook. However you find it is fine with me. In this case, we're going to do 1 or 2 together. You need to actually have your periodic table, and you need to find hydrogen. So take a moment, pause this video if needed, and find hydrogen on your periodic table. A hint, it's the first one, so it should be upper left corner. If you need to pause, remember pause. So in this case, the name is hydrogen. Now I need to find it. And in this case, hydrogen is spelled out and its element symbol is H. The atomic number of hydrogen is in the upper left corner, and that is 1. And if I want to take the number of neutral neutrons, I take the atomic mass, which in this case is 1.008. We're going to round. So 1.5 and higher would round up to 2. 1.4 and lower stays just 1. So in this case, 1 minus 1 means there are no neutrons. It is the only atom that doesn't have a neutron. Hg. Now you need to go find that on your periodic table. Heg is also known as mercury, and it is number 80 on the periodic table. So its atomic number is 80. We're going to fill that in there. Hg, when you found that, is mercury, so you're going to fill this in as mercury. Not the best writer on this, apologies for that. And I need to figure out the number of neutrons. In this case, if you look, you're going to see that the atomic mass of mercury is 200.59. That means we're going to round that up to 201. We're going to subtract 80. And if you do that math in your head, which is fine, 1 minus 0 is 1, 20 minus 8 is 12. So in this case, our number of neutrons is pretty large, 121 neutral neutrons. Now, what you're going to do for the next one is you're going to go find atomic number 29, and you're going to look on your periodic table until you find 29, and you're going to find out that the element symbol for that is Cu. So Cu is 29. Remember, the first one, when we have 2 or more, is always capitalized. The second letter is always lowercase, because every time if we get into a formula, we have an uppercase, we know we're actually starting a new element. So that's just conformity. First one is always uppercase, second one is always lowercase. And Cu is copper. So the atomic mass of copper is 63.54. So 64 minus 29. You want to do a longhand? I do this old school borrowing. This is 5. This is 3. So the atomic mass is 35. I'm giving you basically unlimited attempts on this element box practice because this will be on the test, and I want you to practice this again and again. So there's no reason for you not to have this perfect. Let me know if you've got questions. If I'm not here, obviously you're going to need to email. If I am here, then you just come up and talk to me. Let me know what you need.